Okay, this is the P3 paper from June 2024. It's question number 6. When we get to look at it properly, we can see that there's a little bit of work to do with differentiation because we're going to be finding the equation of a normal, and then later on there's going to be doing some work involving integration to find this area R in here. Okay, so let's have a look at the first part. So the first part says we've got the curve y equals root 4x minus 7, and the line L here, this line L, is the normal to the curve at the point 85, and they want us to show that the equation works out to be equal to that. But that shouldn't be too much of a problem. So part A, first thing I've got to do is to realise that in order to find the equation of a straight line, I want y minus y1 equals mx minus x1, where x1 and y1 are points on the line. Well, I've got those two, but m is going to be the gradient of the line. So if I want the gradient of the line, I'm going to need to differentiate my function. We've got to do some work with normals after that, but let's just at least make a start to it. So the beginning part, y is equal to square root of 4x minus 7. Well, I'm going to write that as 4x minus 7 to the power of a half here. And then I'm going to differentiate using the chain rule, but doing it really, really quickly. So if we're going to differentiate this, then differential of something to the power of a half is half that something to the power of minus a half. Multiply by the power, take one off the power, but then the chain rule always says to multiply by the differential of what's in there, and the differential of what's in there is 4. So tidying that up, that's 2 lots of 4x minus 7 to the power of minus a half. So that's dy by dx. So if I want the gradient at x equal to 8, that's going to be equal to 2 lots of 4 times 8 minus 7 to the power of minus a half, which works out to be 2 times 25 to the minus a half, which works out to be 2/5 when we do it, 2/5 there. Now that would be the gradient of the tangent, okay, that would be the gradient of this line here. We want the gradient of the normal, and we can see they're perpendicular to each other. So gradient x equals that. Gradient of normal then, should absolutely be used to this, should have done this lots and lots of times, is minus 1 over 2/5, which gives us minus 5 over 2. Let's tidy that up. Gives us minus 5 over 2 as the gradient of the normal. So if I then want the equation of that line, equation of the normal, but the equation of any straight line, as I said earlier, is y minus y1 equals mx minus x1. And I always, from all my videos, you've seen these before, will now say what x1, y1 and m are. So it's at the point 85, and the gradient is minus 5 over 2. This is a nice little thing always to do, because it makes you just check that you've got all your points in the right place there. Now just substituting everything in, y minus 5 is equal to minus 5 over 2 x minus 8, and then we need to tidy this up. I'm going to multiply everything by 2 first of all. 2y minus 10 is minus 5 x minus 8, and then going to multiply out that bracket is minus 5x plus 40, and now we can just rearrange this to look like what we had. Remember, we were trying to prove it's equal to something in particular, and that rearranges to 5x plus 2y minus 50 equals 0, and that's what they asked me to do for this first part. Second part then says, can we work out the area of the region R using integration? Yeah, absolutely we can. So this region R then, what I'm really interested in is if I drop this line down here, what I'm going to do is I'm going to work out this as being the area under the curve, so just the integral of y dx, but then the other part here is a triangle, and if I'm going to find the area under the curve and the triangle, I really need to find this point, and this point on the axes. Now remember, we know this is the point 8, 5. So if we know this is the point 85, then I already know what B is. In order to work out C, all I need to do is I need to find when is the equation of the line, when is y equals 0, and in order to find A, I need to know when the equation of the line, when is y equals 0 for that one. So that'll give me those 2 points, and obviously B we've already got as being the x value of my coordinate, so I already know that B is equal to 8. Let's explain that to the examiner now as well. So part B, for my x-axes, now I can say A, B, C if I want to. Yeah, A, this is going to be y equals square root of 4x minus 7. I want y equals 0. So root 4x minus 7 equals 0, which means 4x minus 7 equals 0, which means x is going to be 7 over 4. For point B, that's just going to be x equals 5 straight away. And then for point C, I'm going to have that the equation 5x plus 2y minus 50 equals 0. Again, y is going to be equal to 0 there. So I'll get 5x minus 50 equals 0, which is going to give me x works out to be equal to 10. I'll go back and put them on the diagram then. So we've now got that when we're looking at these values here on the diagram, that this value here was 7 over 4, this value here was 8, and this value here was 10. So what I need to do is to be able to work out the equation of the triangle, half base times height. I've got all the information for that. And then the equation of this bit here as being the integral of y dx, and I'm going to be doing it between 7 over 4 and 8. So now I've explained that to you, let's explain that to the examiner. So if we want region R, sorry, pen's not working, area, so the, it's better, pen's working now. Region R equals the integral of y dx between 7 over 4 and 8 plus half base times height for the triangle. So that's going to be the integral between 7 over 4 and 8 of 4x minus 7 to the half dx, and then the half base times height is going to be a half of 5 times 2, half of 2 times 5 there. So now let's just focus on integrating this part here. If we're going to integrate it, then what we can do is we can take a guess at what we think this is the reverse chain rule. So if I've got x to the power of a half, how did I get x to the power of a half? My integral, I think, my guess would be y equals 4x minus 7 to the 3 over 2. Why? Because when I differentiate that, I take 1 off the power, and taking 1 off the power of 3 over 2 would become a half. So let's actually differentiate that, and then it will tell me what the actual integral is. If I differentiate that, I get 3 over 2, 4x minus 7 to the half, multiplied by what's in the bracket. This is the chain rule again, just like we looked at before. So that all works out to be 6 lots of 4x minus 7 to the power of a half. So what that now means is I know the integral of 6 lots of this works out to be equal to that, but I haven't got 6 lots of it. I've just got this part on its own. So hopefully it makes sense to you to then say that the integral of this bit actually means 4x minus 7. We just need a sixth of that. Sorry, let's just, apologies. 3 over 2. Yeah, a sixth of that between 8 and 7 over 4 plus my half 2 times 5, which is plus 5 here, and now all I've got to do is go and work that out. Now, I'm not going to leave this part on here. This was just to explain to us how to do it. So I can now just move this all out, just for the examiner and what he would see next in terms of my answer. So then we're just going to stick 8 in and 7/4 in. So when I stick 8 in, I get 32 minus 7 to the 3/2, all divided by 6. Minus sticking 7/4 in is going to give me 4 lots of 7/4 will give me 0, won't it? So it's going to give me 0 all plus 5, and that actually works out to be 155/6. And I said the exact value, so I'll leave it as that fraction there. 155/6 is my actual final answer for that one. And yeah, not too bad for what we're up to. We're up to question 6 here. That's a reasonable use of integration to answer that question. Okay, hopefully that all makes sense to everybody.